if I am putting it in a transferred form, clear, I1 dash. So like this, it will come here. Again, I have to split this current, do a lot of calculations. So this is exact equivalent circuit, you can say, but I'm not interested in that exact equivalent. If I can reduce some computational error, computational load, I can reduce some computational load. Yeah. So what will I do? What will I do? I will transfer this just for solution purpose. Just for solving equation, I will transfer this branch to this point. Of course, because of this transfer, some error will be introduced in my computation. Clear? Some error will be introduced, but practically that error introduced is very less, maybe 1 or 2% error. But at the cost of this 2% error, I can save a lot of computational time and process. Okay, that's why I will use approximate circuit, approximate equivalent circuit. Okay, using approximate. So how I will connect this, remove the no load branch. You can call this as a no load branch, and we'll shift it to this point. Okay, we'll shift it to this point. Some error will be introduced. Calculation won't be exact. There will be some error, which is 1 or 2%. But so when I shift this to this point, I get approximate equivalent circuit, but it saves a lot of time. It saves a lot of time. So I can redraw the approximate equivalent circuit. So it will be something like this.
Will I2 dash will be equal to I2? I2 dash will be equal to I2 or not?
I2 dash, actually, I put it as I2 dash. It is now, actually, it is the I2 dash. You can say it is equivalent of secondary current on primary side. Okay. Equivalent of secondary current on primary side. Actually, I should have used some other letter, but I thought it is good to use the same thing. Okay. So actually, I1 minus I0, some current will be there. I1 minus I0 without referring it to either side. I1 minus I0 will be the current flowing through this, and that current will be equivalent of secondary current, and that's why I have put it there. This.
Yes, sir.
Okay, understood it. Symbolically, a little bit. थोड़ा सा
this I2 dash plus I0 dash.
I2 dash plus I0 dash will be equal to I1 dash. Clear?
Yes, sir. Yes, sir.
So now I will be drawing approximate circuit like this. Okay. R1. Just wait. Let me draw the circuit. So my no load branch is shifted here. Okay. My no load branch is shifted here, which is V1 dash. Voltage is V1 dash. This voltage. And this is my I0 dash. Of course, all the dash values, I am not putting it. Otherwise, again, it is going to be complex. R1 dash, X1 dash. Clear? So this is my R1 dash, X1 dash. Now, my direct connection from this will go to the R2. This is my R2. This is my X2. And this is my Z2. Okay? Z2. And the voltage will be V2. Z2 means load. You can put it as a ZL also. So the voltage across that will be my V2. And I told you V1 dash will be approximately equal to V2. So R1 dash is here. X1 dash, R2 dash, R2 and X2 and load. And the current will be I2. I'll just change the color. So the I2 will be flowing through this. Okay? Yeah. I2 will be flowing through this. Okay. Now you see the same current will be flowing all this. So they all are in series. So I can further reduce this circuit to this value. No load branch. Okay. Then I can have one resistor, one reactor, and the load. This is my Z2. Clear? Or a load you can say. And the voltage across this will be V2. I2 is the current. Okay. Now this is a combination of R1 dash plus R2. Similarly, this is the combination of X1 dash plus X2 because they are in series X2. Clear? And this is represented by equivalent reactance referred to the secondary, and normally symbol uses X02. Similarly, R1 dash plus R2 will be replaced by single resistance, and normally R02 will be the symbol or equivalent resistance referred to the secondary. So these are the equivalent X of a complete machine referred to secondary. Same thing is here. Equivalent resistance referred to secondary of a complete machine. Yeah. So we can get R02 and X02, and these values of the machine can be found out experimentally, but it is beyond your scope. Clear? Some tests are to be conducted. No load test and short circuit tests are to be conducted. Just for information, I'm telling you, it is not in your course. So no load tests are called as open circuit tests also. So you have to get conduct that test, and from those test results, you can get these values of R02 and X02. Actually, these are very important parameters because this help us in doing or solving the machine related problem in a simple steps. Okay, so just wait. Now this was done with reference to secondary, but the same thing can be done on primary side also. So I will just delete the portion. Just 2-3 minutes only. Okay, now all the dash has to be removed. Initially we will do that. Okay. Now I want to refer the circuit to the primary. Now equivalent circuit, of course we will do the approximate equivalent circuit. Equivalent circuit refer to primary. Okay, so my primary portion will remain as it is. So it will be, again I am transferring this branch here directly. Okay, this nodal branch I am immediately transferring it to the very first position. So this will be now X0, R0 and I0, original I0 not transferred, because we are transferring the circuit to the primary side, refer to the primary side. So this is V1, which is the applied voltage, and now it will come to this. This is there. Again, this is my ideal machine. This is my R2, X2 and the load. Of course, okay, I'm not wrong here, sorry. X1, R1. Okay, now this was my E1 and this is my E2. Clear? Now I want to transfer this circuit to primary side. Okay, yeah. So what will I do? I have to get the value of X2 dash, and that is getting to be K square into X2 value. K square into X2. Similarly, R2 dash is K square into R1. Sorry, R2. R2 dash is K square into I'm sorry.
R2 upon K square, sir.
Divided by K square. It is divided by transferring primary secondary to primary side. So make this correction. X2 dash is X2 by K square. R2 dash is R2 by K square. Now what will happen? I have to transfer this voltage to primary E2, because my final intention is to get a single equivalent circuit. So I will be transferring this secondary induced voltage to the primary. And how you get? By voltage transformation. Okay? By voltage transformation. So E2 dash is, your basic formula V2 by V1 is K. Okay? Is K. Okay? And I1 upon I2 is also K. So when I send transfer, this is my I2 current now. Okay? So I2 dash, which is equivalent to secondary current on primary side, you can take it is equal to approximately I1 also. Doesn't matter. I2 dash is KI2. That is, this I2 dash is the equivalent current component on primary side, equivalent of secondary current I2. Okay. So what will be the value for this? For V2 dash, what will be the value? V2 by K.
Okay.
Of course, Z also has to be transferred. And so Z2, even including this load voltage, needs to be transferred. So it will become I2 dash, Z2 dash. Same formula, R2, X2 and Z2. Same method. I2 dash, Z dash, X2 dash, R2 dash. Clear? E2 dash. Now E2 dash is equal to, or V2 dash is equal to your V1. This is approximately V1 or E1. Same formula. It is the voltage after. So this becomes E2 dash and it is equivalent of E1. And so equipotential points are there. So I can remove this machine. Clear? I can remove this machine. Now when I do so, what will happen? Again, I'm not going to put all the circuit here. It is same. So again, R01 will be equal to, because of same current, I2 dash will be flowing through this. So R01 will be R1 plus R2 dash. X01 will be equal to, of course, all the other branches as it is. X01 is X1 plus X2 dash, and this is my load, which is equivalent to Z2 dash. And current flowing through this is I2 dash, and current flowing through this is I0. I have not drawn the complete branch, and this is my voltage V1, which I am applying between these two terminals. Got? Okay? So here we stop.
Okay, sir. Thank you.
It is approximate equivalent circuit referred to the primary.